Section 4.4 is on complex numbers. In this section, we're introduced to the imaginary unit, and that is I. I is equal to the square root of -1. This is not a real number, it's an imaginary number. And this is how we deal with taking the square root of a negative number. So here's a few things you should be aware of. So I is equal to the square root of -1. Therefore, I squared is -1, because the square root of -1 times the square root of -1 is going to give you a -1. I to the third power is the same as I squared times I. Remember that when you're multiplying powers, you add the exponents. So that's like I to the 2 times I to the 1 is I to the 3. I squared is -1 times I, which gives you -I. So I to the third is -I. I to the fourth is I squared times I squared, which is -1 times -1, which is 1. An interesting thing, I raised to a power that is a multiple of 4 is always going to be equal to 1. We'll use that in one of the problems we're going to take a look at here. Here's how you write it. So suppose I had the square root of -3. I break that down into the square root of -1 times the square root of 3. Square root of 3 is irrational, I just leave it that way, and I rewrite square root of -1 as I. So the square root of -3 is equal to I square root of 3. Square root of -16 is the square root of -1 times the square root of 16. Square root of 16 is 4. Square root of -1 is I, so I write that 4I. Let's take a look at some examples. So simplify each of these expressions. The first one is the square root of -18. So I want to start by rewriting that as the square root of -1 times the square root of 18. Square root of -1 I know is going to turn into I. Square root of 18 I need to simplify, so let's factor tree that. 9 and 2. I know the square root of 9 is 3, so that's going to turn into, well, this right here is going to turn into 3 times the square root of 2. So I have an I have a 3 square root of 2, and we write it like this: 3I square root of 2. Okay. Second example, 3I times 4I. And we're just going to multiply these. So that's going to give me 12, sorry about that, 12I squared. And remember that I squared is equal to -1, so that's the same as 12 times a -1, or -12. Next example, square root of -20 times the square root of -12. We're not going to multiply these. We're going to simplify each one separately. So the square root of 20 is the square root of -1 times the square root of 20. -1 is I. Square root of 20, that's a 4 and a 5. So that's going to turn into a 2 square root of 5. So square root of -20 is 2I square root of 5. Now let's do the same thing with 12. That's going to be square root of -1 times the square root of 12. 12 factors into a 4 and a 3, so that's going to be 2 square root of 3. And my square root of -1 is an I, so that's going to be 2I square root of 3. Now, let's multiply the parts here. 2 times 2 is 4. I times I is I squared. Square root of 5 times square root of 3 is square root of 15. So that's going to give me 4 times I squared is -1 times the square root of 15 for a final answer of -4 square root of 15. Example number 4 has I raised to the power of 31. Now I really don't want to sit and figure that out. But remember what I said, that I raised to the 4th power, or I raised to any multiple of 4th power, is equal to 1. So I can rewrite this as I to the 28th power, because 28 is a multiple of 4, times I to the 3rd power. Okay, basically just divide this by 4 and see what's the biggest one you can get out of that. So I to the 28th power is going to equal 1. I to the third power is negative I. So that's going to give me a final answer of negative I. Let's take a look at an example of solving an equation that's going to involve I. So here I have 4x squared plus 32 equals 0. First thing I think I would like to do is to factor a 4 out of that. X squared plus 8 equals 0. And I can divide both sides by 4. So that's going to leave me with x squared plus 8 equals 0. And that is not factorable, so I'm going to subtract 8 on both sides. So I'll have x squared equals negative 8. Now I'm going to take the square root of each side. And when I take the square root over here, I'm going to have to do plus or minus. So x is equal to the positive or negative square root of negative 8. And I can't leave it that way. I need to simplify the square root of negative 8. So that's going to be equal to the square root of negative 1 times the square root of 8. And the square root of 8 simplifies into 2 square root of 2. Square root of 1 is I. So my final answer is going to be a positive or negative 2I square root of 2. I take this I and this 2 square root of 2 and kind of write them like that. Don't forget the plus and minus out front. Okay. Now, a complex number is a number that can be written in the form a plus bi, where a is the real part of the number and b is the imaginary part. So for example, here I have a complex number, 3 plus 4i. 3 is the real part of the number and 4i is the imaginary part. So this example says find the values of x and y that make this equation true. 5x plus 1 plus 3 plus 2y times I equals 2x minus 2 plus y minus 6 times I. You'll notice that there is, I'll go ahead and do this in color, we have real parts right here, and we have imaginary parts right here. In other words, the imaginary part is the stuff that's in front of the I. So in order to solve this, I just need to put the real parts equal to each other and the imaginary parts equal to each other. So 5x plus 1 equals 2x minus 2, and 3 plus 2y equals y minus 6. And solving this for x, I have 3x equals negative 3, so x equals a negative 1. And y equals a negative 9. So to solve an equation that looks like this, just identify what are the real parts, which are the imaginary parts, and set them equal to each other. To add and subtract a complex number, we just combine the real parts and then we combine the imaginary parts. So here we have 4 plus 6i minus the quantity negative 1 plus 2i. So I'm going to rewrite this as 4 plus 6i, and let's make sure that we subtract each of these terms. So that's going to be minus a negative 1 or plus 1 and minus a 2i. And here it's really a lot like just combining like terms. So 4 plus 1 is 5. 6i minus 2i is a positive 4i. It just looks a little strange because you're not used to I yet. To multiply complex numbers, we're going to use FOIL. So we're going to multiply 2 minus 4i times 3 minus 2i. So let's just go ahead and FOIL. First is going to give me 6. Outer is going to give me a negative 4i. Inner is going to give me a negative 12i. And last is going to give me a positive 8i squared. Negative 4 times negative 2 is a positive 8. I times I is I squared. Let's clean that up a little bit. Combine what look like terms. But I can't leave this I squared because remember I squared is equal to 1. So this is the same as 6 minus 16I, oh I'm sorry, negative 1 minus 8. So putting it in the correct form, I'm going to have to combine the 6 and the negative 8, so negative 2 minus 16I. Just don't forget you can't leave I squared in your final answer. And our last example here is dividing complex numbers. And this is going to be something similar to what we did with square roots, is we need to multiply by its conjugate. You can't have an I in the denominator, just like you can't have a square root in the denominator, so I'm going to have to multiply by the conjugate of 3 plus 5I. So the conjugate of 3 plus 5I is 3 minus 5I. So we'll have 2I over 3 plus 5I times 3 minus 5I over 3 minus 5I. And when I FOIL on the bottom, it will get rid of the I eventually. So on the top, let's distribute. That's going to give me 6I plus 10, I'm sorry, minus 10 I squared, and I'll clean that up in just a minute, over, and let's FOIL on the bottom, 9 minus 15I. My inner gives me a positive 15I, and my outer gives me a negative 25I squared. So on top, that's going to give me 6I, and I squared, remember, is negative 1, so that's going to be plus 10. And on the bottom, notice these 15 i's will cancel each other out, and I'm going to have 9. And I squared is a negative 1, so that's going to give me plus 25. So let's write this in order here. So I have to have my real part first, followed by my imaginary part, over 9 plus 25 is 34. Now notice that each of those can be divided by 2, so I can do that. So I can divide each of those terms by 2. So 5 plus 3I over 17. And actually the way they like you to write it is to break up that fraction into 5 over 17 plus 3 over 17I. And that shows you the real part of the answer, 5/17, and the imaginary part of the answer, 3/17 I. So in this section we took a look at complex numbers and were introduced to the imaginary unit, the square root of negative 1 is I, and then how to do all sorts of different operations with that.